Okay, today we are going to have a discussion how to write a long answer or short notes on different types of statistics involved in statistical thermodynamics, the syllabus of M.Sc first sem. So, in statistical thermodynamics, the three main stats which are going to be asked in your exams are MB statistics, B statistics, and FD statistics. So, the first one is MB statistics, that is Maxwell Boltzmann statistics. The particles involved or the particles studied under Maxwell-Boltzmann statistics, that is MB statistics, are the particles which are distinguishable in nature. Distinguishable means that these particles can be distinguished from one another. They are identical particles, but they can be distinguished between. We can easily distinguish between these two particles. Then there is no restriction or conditions applied in this case of statistics, that is any number of particles may occupy same state. So there is no certain conditions involved that how to fill the particles in different types of available states. The main formula which comes out to be the last, that is MB statistics, is Ni is equal to Gi e to the power minus alpha plus beta Ei, where Ni indicates the number of particles present in ith energy level. Then Gi is the degeneracy of ith energy level. Then alpha and beta are the constants. Ei is the energy of ith energy level. Where this beta can be calculated as 1, beta is equal to 1 upon kT, where k is Boltzmann constant. So this type of statistics are the first class of stats which we study in statistical thermodynamics. The second is Bose-Einstein statistics. Bose-Einstein statistics in short form, in exam you can have it like B stats, explain B stats or write short notes on B stats. While writing short notes on B stats, you have to start with the type of the particles involved in it. The particles in this case are indistinguishable particles. Indistinguishable particles means you cannot distinguish between these two particles. They are identical and you cannot distinguish between these two particles. Then generally the particles involved in B stats are called bosons. We had already a class on how to identify boson and fermions. The bosons, in short, we can say bosons are the particles which have integral spin. When I say integral spin, it means it is 1, 2, 3 in multiple of some integer. Then these particles will have symmetrical wave function. These particles, and if some new species is given, then you can identify that it is boson or fermion by calculating total number of fundamental particles, electron, proton and neutron. You have to calculate the total number of fundamental particles comes out to be even. That means it is a boson. And there is no restriction. No restriction indicates that any number of particles may occupy a given energy state. In short, we can say, I have actually explained it earlier also, there is no condition means it do not follow Pauli's exclusion principle. There is no restrictions as applied by the Pauli's exclusion principle. These bosons do not follow that Pauli's exclusion principle. There are certain examples which are asked in NET exams also. The final stats which comes as Ni is equal to Gi e to the power alpha plus beta Ei minus 1. The terms indicate the same as they were in MB statistics. In MB statistics, Ni Gi e to the power minus alpha plus beta Ei. This minus e to the power alpha plus beta Ei comes in the denominator with a minus 1 sign over here. So the main difference between this and this is this minus 1. Then let's come to Fermi-Dirac statistics. In Fermi-Dirac statistics, again the particles are indistinguishable. The particles are identical but indistinguishable as in case of B stats. Then these particles have some restrictions that only one particle can occupy one energy state. So as I have said that this condition of the restriction can be stated in one line, that this obeys Pauli's exclusion principle. So fermions, to identify fermions, we can easily say fermions are the particles which have half integral spins like electron, proton, neutrons, etc. Not photon, electron, proton, neutrons, etc. Then the second main feature of fermions is they have antisymmetric wave functions. Then again, if new species is given, then you can identify by calculating the total number of fundamental particles. If the total number of fundamental particles comes out to be odd, then that indicates it is a fermion, as in case of 2He3. Then the final stat which comes is Nigi e की power alpha plus beta I plus 1. So the major difference between these three stats is MB stat. You have to remember MB's formula for the MB stat. Write the formula for the MB stat with a minus sign, minus 1. E की power alpha plus beta A comes out in the denominator with a minus 1 and a plus 1 for FD status. So basically you have to remember MB stats. Then the second one is B stats with minus 1 and the third one is FD stats with a plus 1 in the main formula. So by simply remembering MB stats and to expand your answers in M.Sc theoretical exams, you need to define these fermions and bosons and elaborate your answers accordingly.